Let's work this problem. It looks like a limiting reactant problem, and we are given an amount of aluminum sulfide and water, and the fact that we're given two amounts of our two reactants tells us it's probably a limiting reactant problem. We have some tasks that we're given here. We need to balance the reaction. We need to determine the limiting reactant, and then calculate the theoretical yield of hydrogen sulfide, H2S. So let's do these in some steps here. The first thing we need to do is to balance the reaction, because we can see it's not balanced. And so let's go ahead and do that. We'll just run our elements left to right here. It looks like it'll be a fairly simple balance. So we've got two aluminums in the aluminum sulfide. We've got one aluminum in our aluminum hydroxide. So let's go ahead and put a 2 there. And for sulfurs, I've got 3 in the aluminum sulfide. I've only got 1 in the H2S, so we can put a 3 there. We'll balance the hydrogens next. I've got 3 hydrogens in aluminum hydroxide, and I've got 2 of those, so that gives me a total of 6. And then I've got another 6 from the 3 H2S's, so that gives me a total of 12. So I need to put a 6 here in front of the H2O. And I've now balanced pretty much every component here, so let's make sure that the oxygens work out. I've got 6 oxygens in the 6 waters. Each aluminum hydroxide has 3 oxygens, and I've got 2 aluminum hydroxides, so that gives me 6 oxygens as well. So now we're balanced. Okay, the second step that we want to do is to calculate the number of moles of each of the reactants that we were given. So let's do some mole calculation here. So for the aluminum sulfide, we were given 158 grams, and aluminum sulfide has a molar mass of 150.17 grams per mole. And so I'm going to do 1 mole per 150.17 grams to get my grams to cancel. And that gives me 1.052 moles. Okay, and then for the water, we've got 130 grams of water. So we've got 1 mole per 18.02 grams. And when we calculate that out, we get 7.214 moles. Okay, the next thing we need to do is to determine the limiting reactant. Now, we can't just look at the number of grams that we were given in the original problem, because reactions don't happen in terms of grams, they happen in terms of moles. We also can't just look at the number of moles, because we see that the water with a 6 coefficient and the aluminum sulfide with a 1 coefficient get used by the reaction at a different rate. So what we have to do is we have to take the number of moles of each of our components and divide that by the coefficient that we have in the balanced reaction. So for the Al2S3, we take our 1.052 moles. We're going to divide that by the 1 because it has a balanced coefficient of 1. That, of course, gives me 1.052. And for the water, we have 7.214 moles over, it has a balancing coefficient of 6, and that gives us a value of 1.20. Now, since this 1.052 is the lesser of the two values, that means that it is the limiting reactant, and all of the product that we get, the H2S that we're looking for, must be determined from the amount of aluminum sulfide that we've put in. So the next thing that we want to do then is to convert our moles of the limiting reactant. We'll just call that LR like we did up here. So convert the moles of limiting reactant into moles of product. So just a moles to moles conversion. And to do that, we use the different stoichiometries of the stoichiometric relationship between the two components. So we have 1.052 moles of Al2S3 times, and then I get 3 moles of H2S for every 1 mole of Al2S3. And again, that happens because I have a 3-to-1 ratio between moles of H2S to moles of Al2S3 based on their balancing coefficients. So my moles of aluminum sulfide will cancel, and this will now give me 3.156 moles of H2S. Okay, now my last step that I want to do is to convert the moles of my product to grams of product. So this is just a moles to grams conversion, and we use the molar mass of H2S. So we have 3.156 moles of H2S that we just calculated times 34.09 grams per 1 mole of H2S. So that's the molar mass of H2S. And when we do that, we get 107.6 grams of H2S. So if I put in 158 grams of aluminum sulfide and 130 grams of water, I should get 107.6 grams of hydrogen sulfide out, and that is my theoretical yield.